Hi, in this video I will explain the factors that affect the boiling points of alkyl halides. So in the previous video we discussed the factors which make the boiling point of alcohols higher than those of alkyl halides, and I mentioned that alcohols can have higher boiling points because they can make hydrogen bonds, whereas alkyl halides cannot. So what are the factors which affect the boiling point of alkyl halides? The first factor is the size of the halogen. As the size of the halogen increases, the boiling point of the alkyl halide increases. And the reason is that increasing the size of the halogen will increase what we call polarizability. By definition, polarizability is the property of an element that makes its electron cloud easily distorted and readily to polarize. So to define this or explain this in simple terms, polarizability, so more polarizable element means that it has higher ability to be polar. This is what do we mean by polarizability. So a more polarizable element is an element that has higher ability to be polar bonds. So as the size of the halogen increases, the ability of the compound to become a polar compound will increase. And so the polarity of the compound or the polarizability of the compound will increase, and this means that the dipole-dipole interaction which exists between polar molecules will be a stronger dipole interaction, and that's why the boiling point increases. So again, more polarizable means that higher ability to be polar. So as you increase the size of the halogen, the compound will be more polarizable. It will have higher ability to have higher more polar bonds. Because of this higher polarity, the strength of the dipole-dipole interaction will increase, and that's why the boiling point will increase. If you look at the table here, you can see that by going from fluorine to chlorine, bromine to iodine, so we are increasing the size of the halogen, and the boiling point is increasing from -78 degrees to 42 degrees. Okay. Also, increasing the carbon chain definitely increases the boiling point for the same reasons which we talked about last time, which is as the carbon chain or the number of carbons increases, the size of the molecule increases, and that's why the surface area increases, and then the interaction between the different molecules will increase. So there are two factors. If we are comparing compounds and they have the same number of carbons, increasing the size will affect the boiling point, will increase the boiling point because of polarizability and also because of the molecular weight, because iodine is for sure a heavier element than bromine, chlorine, or fluorine. And the other one factor is the number of carbons. Of course, if you are comparing compounds that have the same halogen, and as the number of carbons increases, the boiling point will increase. Also, the number of halogens will also affect the boiling point. Increasing the number of halogens will increase the boiling point, except for fluorine. And as you can see here, if we have one chlorine, -24, two chlorines, that 40 degrees, and then you have chloroform or trichloromethane, this is 61 degrees, and finally carbon tetrachloride or tetrachloromethane, this is 7 degrees. So increasing the number of halogens will increase the boiling point, again for several reasons. You have more halogens, you have more polarizable elements, and also the other factor is that halogens are heavier than hydrogens. So you are going by increasing the number of halogens, you are actually going to heavier compounds, higher molecular weights, and that's why the boiling point increases. Now, what about the water solubility of alcohols and alkyl halides? Alkyl halides in general are insoluble in water, whereas alcohols are soluble in water. Why is that? Because they can form hydrogen bond with water molecules. So compounds, alcohols with carbons, with 1, 2, 3 carbons are completely soluble in water. And then as the number of carbons increases, the hydrophobicity of the alcohol increases, which means that it becomes less and less soluble in water, because carbon the increase in the chain of the carbon atoms will repel the water molecules, and that's why the alcohol will be less soluble. So for example, if you are given these alcohols and you are asked to arrange them according to their water solubility, the first factor we should look at is the OH groups. Increasing the number of OH groups will for sure increase the solubility, because now you have more hydrogen bonds in the compound, and that's why A is expected to have the highest boiling point. Now, with respect to the other ones, you have to count the number of carbons. This is a C3 compound, this is C4, and this is a C5 compound. Remember that solubility is opposite to boiling point. So in this case, increasing the number of carbons will decrease the solubility, and that's why B is expected to have higher solubility than C than D. So pay attention to this. Solubility and boiling point of alcohols are differ in terms of the number of carbons. In boiling point, increasing the number of carbons will increase the boiling point, whereas in solubility, increasing the number of carbons will decrease the solubility. What about the density of alcohols and alkyl halides? Also, density is one of the physical properties that is affected by the intermolecular forces. So usually if you have high intermolecular forces, the density will be high. So let's look. Alkyl fluorides and chlorides are less dense than water, whereas bromides and iodides are more dense. This is again because of the higher polarizability here. So you have larger elements, you have higher polarizability, you have stronger intermolecular forces, and that's why the density of the compound will be higher. Remember, if you have stronger intermolecular forces, then the molecules will be attracted to each other, which means that the space between the molecules, the distance between the molecules will be smaller, and that's why the molecules will be concentrated and high, and the density will be high. So increasing the number of halogens also increases the density of alkyl halides. That's why, for example, dichloromethane is denser than water, because you have more halogens now. Alcohols are usually less dense than water. And these just are a couple of numbers here. The density, if you have one fluorine is 0.8, chlorine 0.89, and then bromides and iodides, as you can see here, usually the density of water is 1 gram per milliliter. So as you can see here, this is a cut-off point where bromides and iodides are more dense than water.